Hello everyone, my name is Anvita Bansal and today we are back with another lecture based on hash map. So let's have a look what our problem is. Before that, let me check if you guys are able to see me or not. Fine. Okay, so the problem statement for today is array pair sum divisibility problem. So you are given an array of integers and an integer k. You have to tell if among these elements in the array can you form pairs such that it returns true if given array can be divided into pairs, the sum of every pair is divisible by k. So let me explain what they're trying to say is you have this array, right? So from this array pick up the pairs in such a way that the elements of those pairs sum up such that they are divisible by k. So if I take 9 and 3 from this array, so they make a pair whose sum is 12 and 12 is exactly divisible by 6. Let's take a pair 5 and 7. What is the sum of 5, 7? It's 12. It is also divisible by 6. Can you make some other pair? Any other combination of pair is possible. What if we had taken 7 and 3 together? 7 plus 3 is 10 and 10 is not divisible by 6. Or maybe you can check with something else. Let's check 5 with 9. Is it possible to make a pair such that it is divisible by 6? Considering their sum? No. 9 plus 5 is 14. Can you form some other pair? Let's check 9, 7. 9, 7 is 16. No. Again not divisible. Let's check if any other possibility. 5, 3, 8. Not divisible. So this is one such. So you just have to return true if you find such a pair. So let's understand how we can do it. Let me move to the whiteboard. And the example let me take is 9, 5, 7, 3. 9, 5, 7, 3 and your k given is 6. Okay, so what you have to check is one important, this is on the intuition is based on mathematics here. What is the mathematics here? The maths is as simple as this. You want to form a pair, right? Pair will be of some integer x and some integer y, right? And what we want is x plus y should be divisible by k, right? It should be divisible by k. That is what we want. Now tell me one thing, x plus y, can I write it something like this? We do not know if individually x is divisible by k or not, right? Let's say that the answer for this would be pair, taking a pair of 9 and 3, right? 9 and 3 would be one pair and 5 and 7 would be one another pair. Now we know one thing for sure, that we don't know if whatever x we take, and one second, whatever y we take, if individual x and y would be exactly divisible by k. We don't know. So can we write x as, let's say, 6m plus n, right? And let's write this y, this another number y, as you can write it as, why am I saying so? I am just splitting it as if it is getting divisible by 6 and leaving some remainder n, right? And y can be written as 6z plus, let me, 6p plus q, just a convention, 6p plus q. So basically what I am doing is I have two pairs, right? One pair might be of 6m plus n type and another can be of 6p plus q type, where what basically I am writing 9 as what how can you write 9 in the form of 6m plus n? It can be written as 6 1s are 6 plus 3 divisor your, what will be your remainder in this case? 3 is your remainder, so 3 corresponds to n, 1 corresponds to m. And how can you write 3? 3 can be written as 6 into 0 plus 3. So the remainder in this case would be 3, right? So this is just a convention I have written here. Now eventually what you want is, you want the sum of these two numbers. Sum of these two numbers should be exactly divisible by 6. It should be exactly divisible by k. So in order for it to be exactly divisible by k, can you see one thing? I can write it as 6m plus 6p plus n plus q, where n is remainder for capital X. Capital X is the first element, the remainder for that is denoted by n here, and q is the remainder for the second element. So this is the remainder for second element. Again Okay, so this value, I'm doing the sum of these two things. So these two things sum will come out something like this, xm plus 6p plus n plus q. So can you deduce one thing from here, that 6m plus 6p are always going to be divisible by 6 by k basically, because this can be written as this. And what you need to ensure is that n plus q should be divisible by 6, so that the entire sum of this pair can be divisible by 6. You got the catch here? So the catch for this problem is, that whatever pairs you are choosing, let's say your pairs are x and y, right? So the remainder of x and remainder of x plus added to remainder of y, this value should be exactly divisible by 6. You getting this thing? Basically the remainder of this value should be 0 when you divide it by 6. That is the entire catch in this problem. So you took a pair of number x, here 9, another number is 3. So tell me one thing, what is the remainder of 9? Remainder of 9 is, when you divide it by 6. So remainder of 9 divided by 6 will be 3. Remainder of 3 when divided by 6 will be 3 only, right? Because 6 zeros are 0 and here 6 ones are 6. So you are left with 3. Here also you are left with 3. What is 3 plus 3? 3 plus 3 is equal to 6, and 6 is exactly divisible by 6. I hope now you have understood this catch here. Now in this problem, so what are the things that you are going to ensure? Can we ensure it in this way? Let's say whatever test case you had, 9, 5, 7, 3 was your test case. 9, 5, 7, 3. Okay, this was your test case. Now what you want to ensure is, run a loop for all the elements, let's say x belonging to this ARR. What you are doing, you are filling up your map with the remainder, that is x remainder k, map dot put. In map you are putting this and the frequency of that remainder. What do I mean by this? You iterate over this. Now currently you are at this position, okay, you are at this index, right? So what is the remainder when your iteration is at, your index is at 0th position? What is the remainder? So 9 remainder 6 is what? 3. Does map contains 3? No, map does not contain 3. So you will add one key value pair where you will be adding the remainder and the frequency. How many times you have found this remainder? Okay, so I put here 3 right now. Let's say whatever map, I'm not, why did I make a stack here? So you have a hash map in which currently you have 3 as remainder, and corresponding to that you have 1. Now iteration goes to next position. Now you come at this. Okay, so you are at this position now. 1 second. When your I is at this position, so what is the remainder? When you divide 5 by 6, the remainder that you get is 5 only, right? So in your map, in your hash map, do you have any key with 5? No. So you add 5 and frequency is 1, because this is the one time you, now your I is at this position. So 7 remainder 6. 7 remainder 6 is what? It is 1, right? 6 ones are 6 plus 1, 7. So do you have in your map 1 as the key? No. This is for the first time that you are encountering 1. So you will add its frequency corresponding to 1 as 1. Now your I pointer is at this position. So corresponding to 3 remainder 6 is what? It is 3, right? 6 zeros are 0 plus 3 is how you get 3. So do you have 3 in your hash map already? Yes, I do have. So I will increment the count of its frequency by 1. It will become 2. So this is your hash map that it looks like after one iteration on your array, right? Now what is your task? Your task is to find you again iterate over all the elements in your array. You again iterate over all the elements in your array one by one. Now your task is to check. Your task is to check that first thing, if your remainder, one second, whatever, let's say you are at this position, so ARR of I, let it be x. Okay, you are at x. So if x remainder x remainder 6 is equal to 0, first of all you have to check if your remainder is 0, then how can you make a pair? Tell me one thing. Let's say you have this array in which you have 12 and you have 6 and you have, let's say you have 12 and 6. You know that 12 is also divisible by 6, 6 is also divisible by 6. In that case, can I, if I were to write it like this, it will be 6 into 2 plus 0, and this will be 6 into 1 plus 0. So already 6 into 2 and 6 into 1 are already divisible by 6. So n and m here are zeros and 0. So 0 plus 0. 0 as a remainder, that means the number exactly is divisible by 6. So the sum is also going to be divisible by 6. So how you are going to handle is that if your remainder is 0, you just have to, if your remainder is 0, what you're going to check? You're going to check that the frequency of that remainder in your hash map should be even, because only if you have another element with frequency 0, only then you can pair that number. For example, if in this array I modify the array like this, if this was not, do you have any element with frequency with remainder 0? If my k is 6, do you have any number in this array whose remainder will be 0, that is exactly divisible by 6? No, I do not see any element. Let me add one element here, 18. I know 18 is divisible by 6, right? I know. From this part I can already form a pair, but if I have 18, I need to get, can I form a pair of 18 with 3? What will I get? I will get 21. No. 18 with 7, 25. No. 18 with 5, 23. No. 18 with 9, 27. No. So I can see that if I have a number which is exactly divisible by k, I need to have another number to make a pair, so that another number also is exactly divisible by 6. So if I add one more element which is exactly divisible by 6 here, it can be your number 6 only, let it be 6 only. So you know, from here you already formed a pair that you know, and now since 18 is exactly divisible by 6, 6 is also exactly divisible by 6, they both can also form a pair and can be added to your answer. So one important condition here is, if the number is exactly divisible by 6, that means if your remainder is 0, then in your hash map corresponding to 0 as the remainder, so in that case the frequency of remainder 0 should be even. It should be even. That means zero remainder numbers in your array should be in pairs, so that you, because you can only form pair if a number is exactly divisible by k, you should have another number also exactly divisible by k, so that you can form a pair. You can have them in only in the multiples of 2. If you have numbers which are exactly divisible by your k, you can only have them if they are present in the multiples of 2, that is in pairs. Because if the remainder is 0 of a number, then you cannot pair it with any other element in the array whose remainder is not 0. I hope this first condition you have understood. So your first condition that you're going to check is, in your array, first thing what you do is you add the elements, you iterate over the elements and check what is the remainder they are leaving, and corresponding to remainders and how many times you are finding those remainders, that is the frequency, you are forming a map of it. Okay, then you iterate over your map again for int, let's say int x belonging to your ARR, right? And then you are checking, let's say int remainder is what? That element x remainder k, right? What is the first condition you are checking? If your k is 0, right? If your k is 0, so you just need to check what is the frequency of map corresponding to that. So int frequency is map dot get this remainder, that is remainder will be in this case 0. Let me write remainder only. If frequency is divisible by 2, remainder 2, that is not, see, I am going to handle cases and which are going to return me false. So important case is that if the remainder is 0, those numbers, those elements should be in multiples of 2. So the frequency should be like, if it is 0, it should be even numbered frequency. So if frequency is not even, that is it is not equal to 0, then you return false. This is your one condition which will return you false, right? What is the other condition that you need to check in case that might return you false? So the other condition that you need to check is that what are the remainder. Let's say now you come at now you are dealing with non-zero remainders, right? Non-zero remainders. So if I come at remainder 3, I come at first element, I iterate over my first element, my x is what, 9, my remainder is what, in this case 9 divided by 6, what do we get remainder? 3, right? So remainder in this case will be 3. Is 3 equal to 0? No. So you come to the else case condition. So in else case condition, what do you handle is, you want to check, does your map contain a key which is equal to k minus this remainder? You getting this point? K is 6, remainder is 3, that is you want to find if you have another 3 in your hash map. So basically what you want to see is that 3 should also be even in this case, because if your remainder is actually half of k, that means if k is 6 and you get a remainder 3, so you can only pair it with another number whose remainder is also 3. So you want to ensure that 3 is, whatever key is here, if that is half of k, then the frequency should be even numbered. In other cases, let's say when I'm at this case, what is my remainder? My remainder is 5. So I want to check, as we saw here, that n plus q should be divisible by k. So I found n to be what? 5, right? So in my hash map, I want 6 minus 5, that is equal to 1. Because n plus q should be equal to 6. Why 6? Because these are the remainders, and remainders can maximum go up to 6 or the multiples of 6 if there are only two numbers. So the maximum that n plus q can go can be k only, the k value itself. So if I add 1 to it, I can get 6, and this value will be divisible by 6 itself, right? The k. So whatever I find which is non-zero value, I check in the map, do I have, if map contains what? K minus that current number at which I am, k minus remainder. So k here is 6, 6 minus 5 remainder is 5. So you want to check, does your hash map contain whose key is 1? Yes, it does contain, right? If it contains, also you want to get its frequency. Both the frequencies should be equal, because you want to pair them up. If one of them is not equal, you won't be able to pair them up, and that is how you will not end up getting pairs such that from the array, such that what, each pair gives you sum which is divisible by k. So what you want to ensure that, first of all, there might be a possibility that your map might not contain, what if my map did not contain this one? So I want to keep a check. Let's say I take a frequency, int frequency 2 is equal to map dot get or default. This is what I'm going to use, map dot get or default, whatever value I am at, that is remainder, right? That corresponding remainder, k minus remainder, comma 0 plus 1. What does this mean? See, if k minus remainder key is found in your map, that means k was 6, remainder was 5 currently for the element that I am at, right? So k minus 5 is 1. So this method, map.get or default method, says that if in your map 1 as the key is present, right? K minus remainder would be what? Here 1. If 1 is present, then you will return the default value of 1 that is present in your map. So the default value of 1 that is present in your map is 1. And if it is not present, sorry, here will be no 0 plus 1. if it is not present, then you put a key 1 and corresponding to that the value would be 0. This is what this indicates. Understood? So my map dot get or default method I will use, which will tell me that if that key is not present, add that key, and corresponding to that key add a frequency, add a value which will be 0, so that when I compare if that this frequency, if frequency is not equal to frequency 2, right, I want to compare this frequency 2, and if I do not use this get or default method function, right, what will happen is this will give you null pointer exception. The reason being, map will say I cannot find the key that you are asking me, it is not present in the map. That is why what I am saying is, if it is not present, use this method and add a 0 corresponding to its value, so that I can compare at least. Now 0 will not be equal to 1, so obviously it will return false, but at least it will not give me null pointer exception. So this is what I want to handle, and in the other rest of the cases you return true. Okay, so this is how you handle the test cases. Now before I just want to also bring up one thing, but let's first code, then I will come back to here. And there is one actually loophole in the problem setting only, I would say, that in Geeks for Geeks compiler, when the code that I have written here, if we use this pseudocode and code, then all the test cases will pass in the GFG compiler, and it ideally should not pass, because we have not written one test case, we have not handled the test case here, which I will come back after we are done with solving the problem. So any doubts so far, you can ask me. Okay, so what I'm going to do is I'm going to create a hash map of type integer map, new hash map. Fine, I am iterating over my array int I0 I this. I could have used shortened method also, nums dot length I plus plus. If map dot contains key what nums of I, map dot put nums of I, comma map dot get nums of I plus whatever frequency was there, just add 1 to it. That's what you want to add if map already contains that value. Important thing, what I'm doing is I am just adding the nums of I, whereas I want int remainder is equal to nums of I remainder k. That is what I want to add to my map. In my map, what is going in my map, remainders are going, and corresponding to those remainders frequencies are going. Okay, so if map dot contains key remainder, then you put corresponding to remainder, just add one more to what you get at that position, map dot get rem plus 1, right? In the else case, you are adding it for the first time in your map, so map dot put remainder comma 1. Fine, so you are done with this thing. Now again do an iteration over your map, over your array int x belonging to nums, right? So let's check what will be the corresponding to that value, what is the remainder. So int remainder would be x remainder. Okay, fine. Now you will check what is the frequency of that remainder in your map, right? So what is the first case I told you to handle? If your remainder is 0. So if your remainder is 0, you want another value also to be of remainder 0 only. So whenever your remainder is 0, if remainder is 0, frequency of 0 remainder should be even, right? So this is the case we are going to handle. So if your rem is equal to 0, right, because you can only pair it with another element whose remainder will be 0, only then you can form a pair. Let's calculate frequency. int frequency equals to map dot get remainder, right? Okay. If this frequency is not divisible by 2, remainder 2 is not equal to 0, you would want to return false. We are handling those cases which can return as false. In the else case, in the other cases, you just want to check that whatever frequency is, first let's calculate int frequency is again map dot get remainder, right? There is another frequency that you would want to see. Another frequency would be, you are checking if you have some, let's say your k was 6, right, and in your map you have a remainder which is 4, so the other remainder that you would want would be 2, so that 4 plus 2 can be divisible by 6, right? So you will check frequency 2 will be map dot get or default what k minus current remainder, k minus remainder, comma 0. This will ensure that if that value is not already existing in your map, the frequency of that key will be put to 0. Otherwise you get the default value, whatever is present corresponding to that key. So let's, for example, if remainder was 4, right? If remainder, let's say you are at 9, you are at 5, and for 5, what is the remainder in your map? For 5, let me show you here. Let me make one more. Let me do a dry run once again for you. 9573. So what I want to show you is 9573. Let's see what we are doing. What we are doing is, in your map, what is 9 remainder? When you are at this position, 9 remainder 6 would be what? 3. Same for calculate all the remainders. Remainder 2, 5 remainder 6 would be 5. 7 remainder 6 would be 1. 3 remainder 6 would be 3. Now you want to add these values to your hash maps. So hash map would look something like this, that it will have key value. This is key, which is actually the remainder, and value is what? Frequency of that remainder, right? So when you are at this position, you add 3. There is nothing in your map at this position, so you add 3 and the value is 1. When you come at this position, you check for the remainder, which is 5. You ask your map, is it present? No. So you add it and put 1. When you are at this position, you check for the remainder, which is 1. Is it already present? No. So you add 1. When you are at this position, you check in your map, is it already present? Yes, the key is present, so just increase the count of it by 1. Now this is how your map looks like by the end of which iteration? This iteration. When you are done iterating this much, this is how your map is going to look like. Fine. Now I am going to run another loop, which is this. Let's see what this loop is doing. So this loop is again going through each value one by one. Right now it is at this position, at 9. Okay. 9 5. Let me write it here. 9 5 7 3. So it asks 9. What is your value? It asks 9. Tell me in map. First of all, it will ask what is your remainder, right? So it asks what is the remainder. It will give you remainder because remainders are because that is remainder which we have stored in the hash map. So it asks for every number what is your remainder. I am writing the remainders here, so it will tell that my remainder is 3. Okay, so it will ask map. If it is 3, first of all it will check, is remainder equal to 0? This is what we are doing in this first case, right? If not, then it goes in the else case. So else case is doing what? If it is not 0, in the else case, if remainder is non-zero, so I want to check another key in your map whose remainder, if added to the current remainder, can be divisible by k. So k was 6, I already have 3. So it is checking if I have frequency of 3, it will go and ask map. If map contains what? 6 minus 3, that is k minus your current remainder. Got this? Your remainder was this, your k is 6. So k minus remainder, is it present in your map? This is what this function does. Map dot get or default k minus remainder. So map will tell you, yes, I do already have this value. So it will return the default value of this 3, which is 2. Then it compares both the frequency. If frequency is not equal to frequency of 2, it will return false. Otherwise, in the other cases, return true. Let's check for the other example. See, when you come at this position, which position? Now you are at this position. Where is my? Now you come at this position. Okay. Fine. Now you are at this position at 5. So what happens is, what is remainder first of all? For 5, the remainder is 5 only. So you will ask map, is k minus remainder, which is 6 minus 5 is equal to 1. Does your map contain 1? Yes, it contains 1. What is the default value of 1? It is 1, right? So what is the current frequency corresponding to current remainder? Your current remainder is 5. So current remainder corresponding frequency is 1. Then this was your remainder. This is your k minus remainder for this case, right? Because 5 plus 1 will be divisible by 6. That is why you would want a pair whose frequencies match. Only then you can form a pair. And in this case, frequency is equal to frequency 2. Let me write frequency 2. So you will not return false. You will come out and return true for this case, right? So this is how we are handling these cases. Let's check if we are able to compile it. Okay, this is the custom input. Yeah, this is the case I was going to discuss about. Let me just submit it and see. See what a glitch in this compiler. This is what I was going to talk about. So this took me so many attempts to make this question get right. The issue with this problem is, you saw this custom input. I hope till now you have understood the problem. So this is my assumption that this particular problem for this compiler is assuming that you are always going to get arrays which have even number of elements. That means the size of array is even, right? So this is 4 length of array would be always even. Only in that case this solution is going to work. Because if you see this custom case, if you see this test case which I have written it just from my own. So in this case, if I compile, the compiler is going to return me wrong answer. The reason being, this is for sure that it is going to return false, because we cannot form pair. Always one element is going to be left. So you should be either keeping, and otherwise it is submitting. So either you should be keeping a check which checks the length of your array should be even, and then you are doing all of these things in the other compilers. And the other thing that you should check is that when your remainder, whichever you are at, for example, when you were at this position, what was the remainder? This is 3. 3 is exactly half of k by 2, right? So whenever you find such remainders, 0 remainder elements and k by 2 remainder elements, zeros can only form pair with other elements if their remainder is also 0, and k by 2s can also form the pair if they get their frequency as even. So I can only form a pair if my remainder is k by 2, right? So the frequency of this remainder should be even. Only in that case I can form pair, otherwise it should return me false. So either you handle this case separately, but for this I think they have made a bit easier. I wouldn't say it's a glitch. I can say it has made question a bit easier, because you don't have to handle that case. So this is all about this problem. What is the time complexity? For sure, let's come on the space complexity. You are taking a hash map for storing your answers. So at max, the space complexity can go to O of n, big O of n. And for the time complexity, you are using two loops which are not nested within each other. For once, we are putting up the values in the map. For the other, we are calculating the answer by taking out the values from the map. So these are the two separate for loops. So maximum 2n o big O of 2n, so that can be taken as big O of n is a time complexity and O of n is the space complexity. So I hope this much is clear to you all. If you have any doubts, you can ask me in the chat, else we can wrap it up. So this was all about today. Thank you everyone. See you all in the next lecture. Bye bye.